Number 7. Movies have a tendency to over dramatize things. You have to be hit with a bullet this big for you to fly backwards. Okay, that's mm, this is. All right. Second. Okay. Question 8. This actually is more, I think, more revelatory for people. So, when you see skydivers in the movies, you see them getting yanked back up. Okay, and that would be worse than if they would have hit the ground because they're falling, and then all of a sudden they have momentum, and then they don't. Okay, so it's an abrupt change of momentum. But to be yanked back up is going down, stopping, and then going back in the opposite direction super fast. Essentially, what you do is take the harness that you're in and turn it into a human strainer. Like it'd be messy. Okay. You're right. That's assuming the rope didn't break.
So what we see in movies is, do they get yanked back up, or is the camera just still like moving downward?
It is a consequence. The yanked back up is a consequence of the camera guy still falling, and the star of the show is just slowing down. Okay. You've experienced this driving. You're in the left-hand lane, and you're driving by someone in the right-hand lane, and the person in the right-hand lane sees like a tire in the road or something, and they slow down. Relative to you, what does that look like? The car does. Their car does. It looks like it goes backwards relative to you. But did it really? They didn't throw it in reverse. They just slowed down. Okay. So as the camera guy and the star of the show are falling, the camera guy, sorry, the star of the show slows down, but this guy keeps on going. And so it's like, oh, I gotta get the guy in the shot. So it looks like they get yanked back up, but really they just slow down. Good with that? Interesting. All right. Next lesson.
Hey everyone. I didn't know you were actually vlogging.
Crazy. Didn't see that one coming.
What?
I bet he's
I'm actually gonna be fit.
I bet he's gonna learn some editorial skills and then go out.
No. On what?
All right. So.
Yeah, so I'm the 7 Yeah. And the 7.
Here we go.
Oh, sorry, I rattled it. I had to keep it
Here we go. I'll just.
Okay.
There we
Good idea. Hey, I just disrupt my own video because I know you make these for me.
I do. All right. Give this one a shot. Talk to your neighbor.
think it is? Okay, let me actually-
You're gonna hear your answer later.
Oh yeah, I'll hear my answers. And I'll be like, you idiot.
Oh, yeah. Okay. Yeah.
What do you say?
Hey.
A is correct.
Yeah, that's five.
So, if I could leave you with one piece of advice for this, if I can only give you one for this unit, keep an account of direction. Okay, you've got to. Okay, they define which way is positive and negative. So they said to the right's positive. Change in momentum. It's mass times change in velocity. Mass times final minus initial. So you have a positive 20 minus a negative 30. Gives you a change in velocity of positive 50 multiplied by a half. Gives you a positive 25. We said positive is to the right. Good as that? Talk to your neighbor.
So mass times stay the same the acceleration of gravity is always the same no matter what it is. So they would have the same speed and the same weight.
Yours is fine.
Yeah.
Same mass.
So this is after they hit.
After they
After they hit.
Would the change in momentum be greater in the beanbag then? Because it just stops? Or is that like done?
So it's right. So the change is talking about right before it hits compared to right after. Like the beanbag stops and the bouncing ball, the rubber ball bounces back up. Those like in the second, like one Mississippi, which one experiences a greater change in momentum?
Johnny, what do you think?
You said it before me too. I didn't even see it.
Thanks, Johnny. I'm getting smarter by the minute.
All right, here we go. Let's take this example again, and we're gonna turn it so it's like vertical now. So this is dropping. So this is the rubber ball. The beanbag just you remember that? I just stopped.
That'll be a good one though. I'll remember it.
Okay, so what is the correct answer? The rubber ball experiences a greater change in momentum because it goes down, stops, and then it comes back up. It's changing it. So the beanbag goes from 30, sorry, final is 0, initial is a negative 30. It has a change of velocity of positive 30 times 0.5 is a positive 15 versus the rubber ball had a positive 25. Good with that? Okay, now you can make up any numbers you wanted to, but so long as you ended up with 0 for the beanbag. Okay. So there we go with that. It's just like the skydiver getting yanked back up. That was a huge change of momentum really fast versus just hitting the ground as if you didn't have a parachute. Good with that. Talk to your neighbor.
I'm gonna think about it more. It's like staying away.
Here's why because I think it's more time pack.
It's more time. Yes, you're right.
Stuff is more time.
Okay. We're going to try this out. Sort of.
You need help in your vlog.
Nope. So we've got a bouncy ball. Okay. So.
Oh.
There it goes. that was so weird.
Oh.
Okay. We got a happy ball, sad ball.
Guys, even I knew that one. Come on.
Okay. So, which one do you think is the sad ball?
Probably the clay ball.
Okay. So, to make it, so that's like more or less like a beanbag. To make it more like a clay ball, I put Velcro on it. So it's going to stick. Okay. Or, oh, there it is. Our door. Okay. So to make it consistent, I'm going to shoot it out of this launcher here. Okay. So gotta get the all right. 2 clicks back. No, 3 doesn't stick. All right, here we go. We're gonna look to see how far it goes. Ready? 3, 2, 1. That didn't stick. Try that again. Velcro's getting tired.
Wait, we have a bowling ball. Why don't we get like a 5-pound ball of clay and throw both at the door?
First year of my teaching, I did that. Did not go well. 1, 2. Okay, here we go. 3, 2, 1. Nice. Right.
Oh my gosh, what the heck?
Right there. Okay.
Oh, wait. Oh, the bouncy ball's gonna go through.
Are we good? Stuck.
We'll find out when they're together.
Okay. Now, bouncy ball. 1, 2. So, here's where the clay ball hit. All the way here. See that? Nice. Okay, so bouncy ball hits, or it goes further. Why?
Because since it starts going one direction and then when they hit, it goes backwards, which means this one has to go forward more to compensate for that.
Right. When two things collide, they will always experience the same change in momentum. One's going to be positive, one's going to be negative, because they experience the same force for the same amount of time. Okay. The bouncy ball experienced a greater change in momentum because it changed its direction back. Therefore, the door that it hit also experienced that greater change in momentum. Versus the clay ball, well, it just didn't have as great as change in momentum. Now, the popular, and I used to think this when I was in your shoes, it was like totally clay because it sticks. It exerts a force for a greater amount of time, continues to push on it. Okay, here's why that thinking is wrong. As it comes in, as the clay ball comes in, and it squishes, it's deforming. This is when it's exerting a force on the door, causing it to open. Okay, but once the velocity of the clay matches the velocity of the door, it no longer exerts a force to make it open. There's a sticking force, like a cohesion, kind of like putting a piece of tape on the door, but that piece of tape's not going to open the door. It's just going to make it stick to it. But the process of which it opens the door is when it's the velocity of this is different than the door, and then once it's stops squishing, then there's no more force. Does that make sense?
So you're saying that with the quote-unquote bullet that would make you fly back, would a rubber bullet that was smaller make you fly back the same? Like, considering they had the same velocity?
Yeah. Yep. Yeah. Like, have you ever been hit by a water balloon that doesn't break?
Yes.
Hurts more than those that do break. Okay. All right. Give that one a shot. JP.
Is that why the paintballs that don't break hurt more than the ones that
Yeah,
do break?
that's exactly why. Yep. Okay. Correct answer is? Okay. Hey, I did this in class. It's a warm up. Okay. Total momentum of the system is 0 initially. Afterwards, total momentum of the system is still 0. Talk to your neighbor. Correct answer is correct. Correct answer is C. Okay. Now the blow by blow is this: as it throws it, as the ball is moving this way, the cart's moving to the right. But once this hits, after the ball is stuck, it stops. Total momentum of the system is still 0. Ethan.
Oh, are you kidding me? Oh, it does say after. Oh, okay. I was gonna outplay you. So after. Probably not gonna outsprinkle on that one. If you would say, position as a
I know. Came close.
Look, I've Einstein Jr. They call me smart as a trans. I don't know.
That's hilarious. All right. Here we go. Come on. Tell your neighbor.
It just goes through over a body.
Correct answer is. Correct answer is B. So the blow by blow is this. Ready? Cart goes to the right, bounces, cart goes to the left. So the total momentum of the system is still 0 the entire time. Say what? Yeah. No, this is 1. This is where it starts. Boom. Boom. So it's going to the right. Cart's going to the left.
Oh wait, it's a bouncy ball.
It's a bouncy ball. It is bouncing. Last question.
Oh, narc. I look so bad. Oh.
I want to recreate.
Huh? I'm not talking like a therapist.
It doesn't work.
Alright.
Yes, he died.
Oh.
Why did you put that picture?
Oh. Oh God. Actually. Wait a second.
Most of us have. They're both going the same speed.
Well, then it's. They would hit each other.
Okay, here we go. So this one comes to abrupt halt. Stops. What is the total momentum of this system? 0. So when they hit and stick together, what does this car do? Stops abruptly, just like it did if it hit a brick wall. C. Crazy. Have a good weekend.
Mark, cookie.